kids are testing for AP pre-cal. Mhm. All right, so 2C.6 log and function context and data modeling. This is basically just building on to what we've done previously with creating functions, equations from data, given data. This is going to focus on more manually with your hands in case it's a free response without a calculator, okay? And then we'll talk about if it is a calculator, what it looks like. So function modeling comes in handy. It's used a lot of time in business settings. This right here is just data collection. You see the average salary for a church pastor across the U.S. increases as the size of the church increases. The graph above shows the average pastor salaries for various church sizes. Okay, we can. Oh yeah, yeah. We can clearly see. Yeah, those mega churches. We can clearly see that the pattern is what? What type of relationship is this? It's logarithmic. It is a logarithmic pattern. Do we see that? We're concave down, we're increasing, right? It's a logarithmic pattern taking place, okay? This is what part of data analyzing is. It is not just looking at your R squared value, but looking at the given data, how the plot is shaped, and then determining what is going to be the best model for that, okay? So our goal is to be able to accurately do that. So knowing the difference between when to use an exponential, when to use a log, when to use when we get to sine, cosine, and tangent functions. So that's our goal. And that's what function modeling is. Okay. So yeah, and it's things that you've already done before. You did it with linears, quadratics, such and such, right? So it's not that you can't do it. You just have to be willing to think outside of the box and understand that math is really part of the real world. And this is what the data analyzing part comes in. Okay. So for log functions, for a given set of data, if the input values appear to change proportionally over equal length output value intervals, then the log model is appropriate. Okay. The key thing is that we are wanting roughly the same amount of change taking place. And when we're modeling with log, we have two options. We have your natural log, a plus b times ln x, and we have your common log. This pen and this new computer just be fighting. Oh, there it goes. It's so natural log, a plus b, natural log of x, or common log, a plus b log of x. Okay, where a and b are constants, and b does not equal 0. So we're going to focus on those two types of log modeling for now. Up first, it says selected values of the log function L are given in the table above on your notes, but next to your mine, where L of x equals a plus b natural log of x. It says use the given data to write two equations that can be used to find the values for the constants a and b in the expression for L of x. Okay, so we are going to create two separate equations. One equation is going to be in terms of 2, and the other is going to be in terms of using 2 and 3, and the other one's going to be using 5 and 7. Does that make sense? That's because we have two sets of x's and y's to solve from. So my first one would be L of 2, and L of 2 would equal a plus b times the natural log of 2 equals 5. 3. I can count. It's a 3. My bad. You saw nothing. So x is 2, y is 3. So that's one equation. My second equation would be using L of 5. L of 5 equals a plus b natural log of 5 equals 7. Okay, why do I need two equations? What did I just create for myself? A system of equations, okay? That means that at some point there's an intersection that takes place where a and b are going to tell me my value. Intersecting, I'm going to know my value, right? We created a system of equations. That's because natural log of 2 and natural log of 5 are just numbers, right? Does that make sense? So it's just as if we had x plus y equals a constant. Instead of x and y, we have a and b. So your intersection represents your coefficient and your constant for your function. Okay, so we're going to find a and b, and we're going to set it up in the format of a system that we normally would solve. Does that make sense? So if this was a system, we would have 3 equals a plus, and it's going to be natural log of 2 because that's just a number. Does that make sense? And we have 7 equals a plus natural log of 5b. How do I solve this system? I can do substitution. I also can do, what's the other method? Elimination. I can eliminate by multiplying the second one by a negative and combining. Do you remember that? So I can multiply everything here by a negative. And what that does is 3 minus 7 is going to give me -4. And what happens to my a's? They cancel out. They are eliminated. So I'm left with the natural log of 2 minus the natural log of 5b. 5 to the b? What do you mean?
There's a b on the outside of the wall. It's actually next to it. Like if you had 2 log 3, it'd be log 2.
It doesn't have to be. Yeah. You remember that rule goes back and forth. The power rule, where your power is either a coefficient. Is that what you're asking? Yeah. The power property goes back and forth. We're treating b as if we would treat y. Okay. So when we combine these two, we end up with subtracting natural log of 2 minus natural log of 4 times b, right? We subtract and then multiply. So from here, we can say what b is. What is b? B would equal what? If this is multiplication, well, what I need you to get b by itself. There we go. It would equal -4 divided by the natural log of 2 divided by 5. Does that make sense? Do we all understand why I wrote 2 divided by 5? What does it mean when you're subtracting 2 logs? You're dividing them. Do you remember that log property? It's the quotient property for logs. Okay, that's our exact value of b. Does that make sense? So that's the exact value of b. So if I didn't have a calculator, this is where my b would exist. Make sense? And we plug b into one of the equations and solve for a. Okay? Yep. And so I personally wouldn't give you this as a what do you call it? Non-calculator. It wouldn't be a non-calculator. For me, it would be a calculator, because therefore you're going to give me an exact value and it's going to make your b all that good things. So now we're going to solve for a. Does it matter which one of these you choose to solve for a? No, you're going to plug b into either one of these, and wham, bam, thank you, ma'am. You now have the exact value of your a. So if I choose the first one, so if I let a equal, and it's going to be 3 minus b times the natural log of 2. Does that make sense? I went back to the original. So here's the original. And I want to get a by itself. And either one of these, I would have to subtract, right? So whether I'm getting a by itself here, this is going to be 3 minus b log of 2. This is going to be 7 minus b natural log of 5. Does it matter which one I use? No. I'm just going to do, I just thought we were okay with me writing it here. Is that okay? Okay. 3 minus, and b is -4. So plus 4 natural log 2/5. I have a negative -4. So it would have been minus, and it's already a negative. Oh, hold on. I'm trying to shortcut it, and I apologize if that's throwing you off. I will not shortcut. So I want to make sure you understand. First thing I did, I subtracted to get A by itself. So A equals 3 minus B natural log of 2. The next thing I did was substitute in for B. So we get A equals 3 minus -4, which makes it a +4 natural log of 2/5 times the natural log of 2. Yes? It's over 1 multiplication. So these are my exact values, and I can condense more and keep going with the 4 natural log of 2 over natural log of 2/5 and make it into subtraction. But we're not going to do that. We're going to stop here. And then these are exact. So now to find the approximates, we're just going to plug this into the calculator and find our approximate values for our A. Open up Sylvie. Hey, girl. And in Sylvie, we have 3 plus, and I'm going to do 4 natural log of 2 divided by natural log of 2/5. And if you don't like reducing along the way, you can keep everything as a whole. Like it's the calculator is going to do the work for you if you're using a calculator. Does that make sense? And hit enter. And I got negative point. Let's round to the nearest 4 decimal places. So negative 0.0259. So negative 0.0259. And then we're going to find our B. Perfect. You found it for us. What is it? And our B is going to be approximately 4.3654. So now we have our A, our B. Can we write the natural log equation that represents this? Yes. So we know that L of X equals, I don't want to write it there. It's not enough space. L of X equals A negative 0.0259 plus 4.3654 natural log of X. And that would be our natural logs that represents us. Now the thing here, you're like, why can't I just go over a regression model? Did anyone ask that? Anyone think about that? But I just do. We are, just in case it's right.
Yeah. Well, you just put those values in.
And you do the regression model, which we're going to model here in a minute. Okay. But are you comfortable if it's not on a if it's on the non-calculator, being able to set up your 2 systems, finding A and B? Okay. My logic is that if they gave this to you as a non-calculator, your numbers would be nicer. Does that make sense? That's what I would assume, is that you would have nicer numbers to work with. At least that's I would give that. I would hope so. Otherwise, then to calculator you go, okay? All right, so now we're gonna practice and remember our regression model using our actual calculator to find the best fit, right? Not the best fit, it's gonna tell us to make a linear. So here we go. The table above shows the data of the graph from about the choices and what their salaries are, right? We're going to use the regression capabilities of our calculator to find S of P, A plus B, natural log of P, where P represents the church size and S is the average pastor salary in thousands of dollars, okay? So we're going to go through those steps. I'm going to open my handy dandy calculator. I'm going to reset. So I'm going to put second plus 712. Second plus 712. I'm going to go to stat, edit. Stat edit, and I'm gonna put in my values. So we have 75, 120, 250. Then we have, I did. Oh, and I also am doing it backwards. It says that our X on our table was our church size. So I need to put in, I am putting in church size. Oh, 120 there. 250, 300. No. I don't know what is wrong with me. 250, 300, 450, 650. It's so much faster when the calculator is in your hand. All right, so there's our population of our church. And then based on that, you make 42,000. You make 58,000. You make 70,000. You make 79,000. 88,000. 95,000. 110,000. What are your churches doing? 125,000. 138,000. Houston, 175,000. Gotta be Houston. All right. So all my data is in. Now, what are the steps I take to find my regression model? Somebody, anybody, everybody. Stat. Calc. You want LN reg, right? Natural log regression, LN. I don't think so. I've never pressed it. I don't think there is. Lin reg. And we're going to store it. Vars. Calculate. All right. How'd we do? Okay. So we found our model. Our model is, let's round to the nearest 4 decimal place. I'm going to be lazy and let it do it itself.
So we only use regression model whenever they give us a lot.
Yes, the more value you have. When they give you the 2 is when you should be, yeah. We did a LN natural log number 9. We did number 9.
Wait, okay, what's the difference between number 9 and number 10? Like the lin reg and then the lin reg with the AX.
That's a linear regression.
Well, there's the other linear.
That's something for stats. Something with stats. So we're not going to worry about it. I mean, you can if you want, but I'm not going to.
I won't worry about it when it's out.
S of P equals negative 91 plus 29 and 9,088 10,000ths natural log of P. Okay. All right. Once I have an equation, I can do anything that it asks me with. So it says, using the model, found in part A, what is the predicted salary in thousands of dollars for a pastor whose church size is 500 people? So we're plugging in for our population. So we now have a value for P. So population is 500 equals negative 91,5,420 plus 29. Now, the beauty about us storing it is that if we didn't want to have to write all that out, what can we use? We can go to our graph or our table and just plug in the value. Does that make sense? So if I go to my table, it's not at 500, but how do I make it go to 500? Table set. Second window, and I say, I want 500. And guess what it's going to do? It'll take me to 500, so that I don't have to scroll all the way down to 500. So they're at $94.3 thousand a year. 0.329, 94,000.
Right?
Yeah. I'm just gonna write it in thousands. You can write it all out if you want. 3,000 of dollars. I'm gonna use words. Of dollars is how much they would be making a year. I don't make
Ms. Jones, I think it's time for you to change profession.
that. Go preach to the masses.
It's 500 people.
It's a lot. Just need 500 people wanting to hear me and listen to the words that are coming out of my mouth. All right, so we got through almost all of this. I will do the report for the last one. Okay. All right, so it worked out. Tomorrow should be a classwork day of this section. Yeah. Mhm. That was a goal.
Yeah.
I'll finish the video and then you'll just have. This one?